Welcome to my new lesson on test for the presence of gases. This is my super and simple lesson I am going to teach you today. Test for gases. Now, we understand that previously we did a lot about the identification of anions and the identification of cations. But definitely in chemistry, it is also important to look at the identification of gases. How do you tell from the chemical reaction that certain gases are being produced? And this is the main purpose of this topic lesson today. Without wasting time, we are going to go direct to what we are supposed to learn. Now, when we say test for gases, we are talking about the identification of gases when a chemical reaction is taking place. If at all possible, some gases are being produced from such a chemical reaction. Now, what do we look at when we are identifying gases from the chemical reaction, or when we are performing a practical where gases are involved in that experimental arrangement? So we are saying when recording observation for gases, it is important to record the presence of effervescences, if any. So we are saying it is necessary when we provide the reagent to you, and when you mix up those reagents, you find that there are some effervescences or bubbles that are given out. It is very important as for you to report that you observed the production of bubbles. That indicates that indeed a gas is being given out, because that is an evidence enough to show that there is a gas which is being produced from the solution. Because when in a solution we have a gas which is being produced, we are going to observe bubbles coming out, informing us that a gas is being produced from such a chemical reaction. Now, since these bubbles are only possible if and only if that gas which is being produced is not soluble. If the gas is soluble, it is not possible that we can observe bubbles coming out from that test tube where that gas which is soluble is being produced. For that reason, we may not see effervescence or bubbles. What are we going to look at if at all the gas is being produced but it is soluble? It may be able to smell. So if you smell a gas, if at all possible the examiner allows you to smell, if the examiner allows you to smell, it means that that smell which is coming out of that experiment is not that toxic. So it is very important also to follow instructions. So we are saying you can record the smelling of a gas or the odor of the gas. Number 2, or number 3 should I say, we can also perform what we call a chemical test for the presence of a gas. Some gases, when they are being produced, they can be identified by performing a chemical test, which is going to entail the production of that gas. It is also necessary, if at all possible, directed to name. You are supposed to name the gas after identifying it accordingly. And without wasting time, we can look at the table where we are going to learn on how we identify gases according to their names. Excuse me. So we are having the name of the gas, color and smell, test method, and the positive result. So, definitely we are not going to give you the name of the gas under experiment. What we are going to do, we are going to give you the reagents where you are going to perform an experiment. And we ensure that for the positivity of any production of oxygen, we will provide the reagents that when you mix them, you are going to produce oxygen. Now, how are you going to know that indeed oxygen gas has been produced? You are going to look at the positive results from the chemical reaction. We understand that this gas, oxygen gas, is colorless. You cannot see it under observation. It is also odorless, meaning it does not smell. You cannot smell it. Even as I'm talking to you, I am taking in oxygen, giving out carbon dioxide, but I am not smelling this carbon dioxide I'm giving out. I am also not able to smell oxygen which I am taking in. Therefore, you cannot identify oxygen gas by smell. Now, what are you going to do? We have what we call the test method. We understand, all of us, my dear learners, that oxygen supports burning. Now, since oxygen supports burning, it's possible that when you introduce a glowing splint in the test tube containing oxygen, that flame or the glowing splint is going to increase in size. That is what we mean when we say it lights a glowing splint. So if oxygen is there in the test tube, immediately you introduce a burning splint or any glowing splint, you are going to observe that that glowing splint is going to relight, meaning the flame itself is going to increase in size. By that observation, you are going to know that you are from the chemical reaction, oxygen gas is being given out. So take note of this test method. That is oxygen. Hydrogen gas. How are you going to know that there is hydrogen gas being produced in the chemical reaction? Again, hydrogen gas is colorless. You cannot see the color. Number two, it is odorless, meaning it does not smell. Now, the behavior of oxygen and the behavior of hydrogen on the burning splint or on the glowing splint is different. Remember, on the oxygen we introduce the glowing splint, meaning we are not interested in the flame only. No, provided there is fire present on the stick, you are going to observe the change. But on the test for the presence of hydrogen, definitely we need that splint to be burning. Why? Because if hydrogen is there, we are going to hear the pop sound. Now, we cannot get the pop sound if we are just having a glowing splint which is not producing a flame. We are interested in a flame, and that flame is going to be put out or put off with a pop sound. And that is an indication that at that point we have formed water. When this substance is formed, we expect the burning splint to stop burning because what we have produced does not support burning. Hydrogen itself is a fuel, only that when it is burning, it burns with a pop sound. And at that point where water is going to be produced, we expect the flame to go off or to be put out because water vapor which has been produced does not support burning. That is very important, my dear learners. At that point where we hear the pop sound, that indicates the production of water vapor. At that point, oxygen reacts chemically with hydrogen. Now, since hydrogen is going to burn with a pop sound, that indicates the presence of hydrogen. That is very important, my dear learners. Understand that. Then we have carbon dioxide. Carbon dioxide also is colorless and it is also odorless. Now, we use a chemical known as calcium hydroxide. Calcium hydroxide in aqueous state is commonly known as lime water. Now, when we bubble carbon dioxide to lime water, this carbon dioxide is able to react with lime water to form an insoluble salt which is known as calcium carbonate. And that calcium carbonate now turns this lime milky. So, the production of the solution or the precipitate which is formed entails that there is carbon dioxide, because in the first place calcium hydroxide in aqueous state will be clear, but after bubbling this carbon dioxide in the container having a clear calcium hydroxide, you are going to observe the fluid or this clear solution turning milky. That entails the production of the white precipitate of calcium carbonate. That is very important. Moving forward, we have another gas we call ammonia. Ammonia is colorless, but it has what we call a pungent smell. The taste method is not there, but immediately we have this ammonia being produced, of course we will be able to to smell this pungent smell, but this is not a good smell. Therefore, it is not advisable as for a student to smell this gas as it is toxic. Therefore, to test for the presence of ammonia, since ammonia is a base, it has the effect on the litmus paper. It is not every time that the examiner will tell you that you are supposed to introduce a damp red litmus paper to a test tube where ammonia is being produced. But what we are going to do, we'll make sure that we are going to provide that red litmus paper on your bench where you are doing your experiment. So you are supposed to know that, okay, this red litmus paper has been provided for the purpose. So you are going to introduce a red litmus paper to the test tube where you are trying to test for the presence of ammonia. And if at all possible ammonia is being produced, it is going to turn this damp red litmus paper to blue, indicating that this gas which is being produced is basic, because only basic substances are able to turn a red litmus paper blue, and ammonia is the only gas that exists as a base. Therefore, that is a test enough to indicate that from the reagent or from the chemical reaction, we are having ammonia being produced. That is very important, my dear learners. What else do we need to understand about gases? Look at this. How are you going to be distinguishing ammonia from chlorine? Chlorine actually is a yellow, a green gas, but ammonia is colorless. Just like ammonia, chlorine has that pungent smell. And the difference is that ammonia is colorless, while this chlorine has the yellow-green color. Just like ammonia, chlorine has the effect on the blue litmus paper. We understand that chlorine is acidic and it has the effect of an acid on the blue litmus paper. All acids stains blue litmus papers red. Now, chlorine is different from acids because for chlorine, what it does, it is going to change, its presence is going to turn this blue litmus paper to red, and then it is going to bleach it. And that is now a proof that what we have is not just an acid, but a gas, chlorine, which has the ability to bleach a red litmus paper. I want you to understand, we are saying for chlorine, it is going to turn a blue litmus paper red because of being acidic in nature. But not like other acids. From there, you are going to observe that this red color, which is going to be observed, will then be bleached. Meaning, you expect that red color to change to something looking white. So we understand that chlorine is able to bleach the moist blue litmus paper. That is very important, my dear learners. Very, very important as for you to understand that. Take note of the important points. So, this pungent smell is not the final detection of ammonia and chlorine. You cannot tell the difference from the chemical reaction depending on the smell. That information is not enough because chlorine has a pungent smell, ammonia has also a pungent smell. So, yellow-green, that is chlorine. Colorless, that is ammonia. But again, looking at colorless, we cannot tell that this is ammonia because we also have some other colorless gases such as carbon dioxide, hydrogen, and oxygen. So again, that is not a proof enough that we can identify the presence of ammonia by looking at the color. That's the reason why we have what we call identity test of gases, because only the identity test of gases gives us the proper identification of these gases. Going forward, we look at the last gas, sulfur dioxide. Sulfur dioxide, we are able to see that it is colorless, just like ammonia. And it has that pungent smell just like ammonia. So meaning the gas being colorless or being odor, it doesn't give us information that this gas is ammonia or this gas is sulfur dioxide. That information is not enough. The positive results. Now, sulfur dioxide is also acidic, just like chlorine. Since these two gases are acidic, this sulfur dioxide has the same effect just like chlorine, because it is also able to turn moist blue litmus paper red, as we can observe there. That information is not enough, because that is the behavior of every acid. Now, the proper identity test of sulfur dioxide is down here. Only sulfur dioxide is able to turn orange acidified potassium dichromate 6 to green. So meaning this reagent acidified potassium dichromate is orange in color. And the presence of sulfur dioxide in solution causes this substance to change to green. And that is the only way as for you to know that the gas which is being evolved from the chemical reaction is sulfur dioxide. You, my dear learners, take time to go through this work so that you are able to carry out experiments very well. And for those I teach, I am planning to give you a task on the identification of ions, and these are the principles I am going to be looking at. So make sure that you understand this video. You also need to like it by subscribing effectively so that you can support me in one way or another. For now, I am going to say thank you for understanding. Those who are revising, revise wisely. Those who are learning this content for the first time, you enjoy to learn new concepts. Thank you so much. As at now, I'll say bye until next time. Thank you.